Okay, ladies and gentlemen, welcome to the video. Today I'm going to be addressing a very important matter, and that is the evolution of the structure of the atom. Okay, so this is typically a Gcse exam style question you could get of comparing the nuclear model of Rutherford and J.J. Thomson's plum pudding. So it's very important that we understand how the atomic structure changed. Okay, so this is a question we'll be able to answer at the end of this video. Okay, so the first most important thing is to understand what is the modern day atom, how does it look like? Now, the modern day atom it has a nucleus, it has these electron shells, and it has electrons. Let's have a look at that, how it looks like. So this is how the modern day atom looks like. We've got the protons and neutrons in the nucleus, we've got protons there, we've got the neutrons over there, and we've got electrons. Now it's important to understand protons are positively charged, electrons are negatively charged, and neutrons are nothing, they don't have a charge. So it's important to understand that concept, okay? Also, the masses of them. The mass of a proton is 1, the mass of a neutron is 1, and the mass of an electron is 0.005, almost nothing. Now, most of the mass of an atom is located in the dense part of the nucleus, over there. The rest of it is not very really dense at all. Okay, now, this model atom that you see here, it wasn't always believed to look like that. Believe it or not, this wonderful scientist here who discovered the electron, okay, he was famous for this model. He said the atom looks like this, and they called it the plum pudding model because it looked like a plum pudding. He said we've got negative electrons over here surrounded by positive pudding. But of course this wasn't true. If we look at a plum pudding, by the way, it looks like this. So I'm getting hungry, by the way, right now. It didn't have plums in it, it had raisins in it. Do you get me? Like plums were called raisins probably back in the days. I don't know, it's kind of a really old school dessert, okay? So, now it's important to understand that J.J. Thomson said that the atom looks like a plum pudding, but of course it doesn't. And how was that proved? By this famous experiment carried out by Geiger and Marsden, and of course the one and only Ernest Rutherford. Now Ernest Rutherford was a proper particle physicist. What he did was an ingenious idea where he said that the plum pudding is not real. How did he prove it? What he did was ingenious. He fired alpha particles at a gold foil, and about 1 in 8,000 rebounded. And he was like, huh? What does this mean? He basically discovered the nucleus. It's because when you're firing on an object that's basically mostly empty space and you get one coming back, that means there's something dense inside the atom, and that was the nucleus. And what he did was he basically disproved that model he disproved the plum pudding model, and he invented his own way of the way it looks like. So he fired alpha particles at gold foil. Most of the alpha particles just went straight through, except for 1 in 8,000 rebounded back. Okay, so this is what happened. Ernest Rutherford and his scientists conducted an experiment where they fired alpha particles at gold foil. The results were revolutionary. They found out 1 in 8,000 rebounded, showing that the nucleus is the dense part of an atom. Most of the particles just went through, as majority of the atom is empty space. Okay, so now we know the differences between the atoms. It wasn't just till later on until Chadwick invented the neutron, and then that's how the new model of the atom was there. So for example, at this time there weren't no neutrons, so you need to remember that. Okay, so it's important to understand that Ernest Rutherford then won a Nobel Peace Prize. Okay, so this is Rutherford's nuclear model. Okay, he said the nucleus is which contains neutrons and protons. At that time he didn't know about the neutrons. Okay, so he's important, and then he said the electrons were around. So he was a lot more closer than J.J. Thomson was, okay, with the plum pudding model. Okay, so hopefully now you'll be able to answer this question. Compare the differences between the plum pudding and Rutherford's standard model of the atom or the nuclear model. Include later developments in the nucleus. You will be assessed on the quality of written communication. This is a typical exam question requiring 6 marks. Okay, so let's see what the mark scheme says. You can pause the video and have a go. Okay, nuclear model mass is concentrated at the center. That's one big difference. The plum pudding model, mass is evenly distributed with the positive pudding around and the sort of negative electrons scattered around. Okay, nuclear model positive charge occupies only a small part of the atom, whilst the plum pudding model positive charge is spread through the atom with that pudding. Okay, so there's a number of differences. It was later discovered the nucleus was separated into protons and neutrons. That came later. So it's important. Nuclear model electrons orbit some distance from the center of the nucleus. Plum pudding model electrons embedded in the they're sort of embedded towards the center and a little bit out. So there's the answer. So hopefully now you've understood the differences between the plum pudding model, the nuclear model of Rutherford, and looking at the actual modern day atom. Thank you very much.